during the beginning of 19th century, so what happened was lots and lots of scientists were working on one very important part of physics. That was atom and splitting of atom. Okay, so that became a huge thing because so it started around 1840s, 1830s during that period of time. Well, so John Dalton, that guy, he told that atoms are the smallest particles which cannot be further divided. Then after that, J.J. Thomson came. So J.J. Thomson told that no, there are certain smaller particles inside an atom. So he named them as electrons. Then Rutherford came. So Rutherford, he gave that atom consists of a nucleus. Okay, so and then he said that all the electrons will be revolving around the atom, the nucleus. So like this, there are different models. So during that period of time, this part of physics, that is the atomic and nuclear physics, was at its top. Now, what happened was, so as different people came up with different ideas about atom and how it actually, how it is and how it presents itself. So then what happened? As they keep on doing different experiments, so one person saw that there was discharge, or you can say electrons were being emitted. Okay, so to figure out more about this emission of electrons, so what he did was he took different metal pieces and then different types of radiations was bombarded on that metal piece. Now, why a metal piece? Because metals are abundant with electrons, right? We have valence electrons. We have abundance of valence electrons. So because of that, metals were used. So electrons started being emitted from a metal surface. So they divided the emission into mainly three categories. One is thermionic emission, another is field emission, another is photoelectric emission. So when it comes to thermionic, see, thermal, what do you mean by thermal? Heat. So we heat the metal surface, so electrons will gain energy, they'll get emitted. So this is one type. Second is field emission. So field emission is where we have two metal surfaces, huge electric field is given between them. Okay, so because of that extreme electric field, electrons will jump, or basically electrons are being emitted. This is field emission. And the last one is photoelectric emission. So photo meaning light, correct? So a light falls on the metal surface and electrons are being emitted. So these are the three main types of emission. So since we are talking about atomic model and atom, related to atom, now, so after this, like different types of emissions were there, people were started doing experiments and people started doing all different types of inventions and discoveries happened during this period of time. In all these models, electrons were considered to be particles, correct? But then after around 1910 or 1905, so this photoelectric effect came. Now here, one huge thing happened, that is this nature of electron was decided to be almost, it was decided to be a wave itself. See, light was considered almost to be a wave because interference happened, diffraction happened, polarization happened, lots of these phenomena happened, correct? So light was almost considered to be a wave itself. It was declared to be a wave. But then this photoelectric emission happened. So photoelectric emission proved that light is a particle. So now we were introduced to a whole other concept of physics, that is a radiation can act as a particle. So a particle can also act as a radiation. So what we get is dual nature of radiation. So this is going to be the main focus of this particular chapter, how light behaves as a wave and as a particle. Light behaving as a wave, you guys have already learned it. So now in this chapter, you will learn how light behaves as a particle. Okay, that's where we learn about photoelectric emission.